Okay, so yesterday we talked about different types of postulates and theorems. We may not have come out right and called them postulates and theorems, but we talked about different angle relationships, like alternate exterior angle. Well, when you use the theorem states that they are congruent angles because they are alternate exterior angles. Or definition of bisect. When an angle or a side is bisected, the definition of a bisector tells us that they're two equal angles or sides. Definition of parallel lines, definition of perpendicular lines tells us that we get two 90-degree angles when they touch each other. Alternate interior angles, corresponding angles, a linear pair tells us that they're 180 degrees. Vertical angles, if they're vertical angles, they are congruent. That's what these definitions all provide you with. So using these definitions up here, we are going to look at how to write proofs. So last year you guys wrote proofs in Math 2, and we didn't get in a whole lot of detail with them. We're going to get in a little bit more detail, but nothing too extreme still. So the first thing in a proof that you always do is start by writing your given. So we were given that A is parallel to B and C is parallel to D. And the reason for that is because it was given. So that's a fairly easy start. So now we're trying to prove that angle 1 is congruent to angle 13. Well, looking at angle 1 and 13, they have no relationship right now. However, if you look, and we're going to talk about it out loud and then we'll put it in a proof form, angle 1 corresponds to 5, and then 5 corresponds to 13. So the first step we can write is that we know that angle 1 is congruent to angle 5 because of the corresponding angle postulate. Okay, and I'm going to kind of simplify that for a bit. So we know these are congruent because of corresponding angle postulate. We can also say that angle 5 is congruent to angle 13 because of the corresponding angle postulate. So the transitive property, which we used some last year, may or may not be fresh in your memory. The transitive property states that if two things, A and C here, equal the same thing, then they have to equal each other. So if A equals B and C equals B, then A has to equal C. So down here, if 1 is congruent to 5 and 13 is congruent to 5, 1 must be congruent to 13. So we can say angle 1 is congruent to angle 13 by the transitive property. So that is proving angles by parallel lines. Okay? So let's look at a few things that we discussed last year also. We talked about triangle congruences, and you guys may not remember exactly what they are, but you should have memory of angle, side, angle, side, 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 angle, side, and hypotenuse leg. Those are the 5 triangle congruence postulates that we talked about. So when we have angle, side, angle, it looks like this. Angle, side, angle. Remember, it has to go in that direct order, from one angle to the closest side and then back to the closest angle. So it has to be the same on both triangles to be considered congruent. So it's when two triangles have congruent angle, side, angle in that order. Okay? Side, angle, side is when we go side, angle, side. Side, angle, side. And it has to be in that order too. It could have been, and let me just show you for a second. It could have been side, angle, side. It doesn't matter where you start as long as they both have the same ones. And it's going in that order. Side to the next angle to the next side. So this is where two triangles have congruent side angle sides, and they have to be in the same place. So in that order, and corresponding. Like for example, if I have, and I'll draw it up here real quick, if I have a triangle that looks like this, and another triangle that looks like this, we're going to pretend like they're the same. If I say side, angle, side, this one has to be that same side, angle, and side. Like it can't be side, angle, side. It has to be in that same exact position. Okay, so that's a little side note. All right, so the next one is side, side, side. Side, side, side. So that's when all three sides, so two triangles have all three sides congruent. And remember, it has to be the same place. So if this side corresponds to this side, those two have to match. If this one corresponds to this one, those two have to be congruent. And if this corresponds to this, those two have to be congruent. So it has to be in the same place in the same order. All right, so angle, side, angle, or angle, angle, side, I'm sorry, angle, angle, side, angle, angle, side. So if I started here, I have to go to the next closest angle and the next closest side. Okay, so this is called, this is when two triangles have two angles and a side congruent in that order. So remember, if I start with this angle, I have to find the corresponding angle and start there and go in the same direction, same pattern. Angle, angle, side. All right, so hypotenuse, leg is the last one. This is only for right triangles. So only for right triangles. This can only be used for right triangles. And this is when the hypotenuse and a leg that are corresponding are congruent. So two right triangles have congruent hypotenuse and leg. And again, that leg has to be the same leg. See how it's the one directly beside the right angle with the hypotenuse above it? Same thing. Hypotenuse, leg, hypotenuse, leg. They have to be in the same position on the same one. All right, so over here, this is a little side note. It's called the donkey theorem. You can't travel by AAA, right? So you cannot have AAA by donkey. We all know the other word for a donkey, but I wrote it backwards here. To triangle congruence. So you can't travel by donkey to triangle congruence. So you can't have AAA and you can't have ASS. Those are two things that you cannot have in triangle congruence. Okay? So there's a little reminder to help you remember that. So let's flip over on the back. All right, let's look at a couple more pictures here to make some proofs. So first thing is you start by writing your given. So J is the midpoint of IL, and J is the midpoint of HK. These are both given. So that's where we start. All right, so we always go off of our givens to get our next statement. So if J is the midpoint of IL, so IL runs here, and J is our midpoint, that means IJ is congruent to LJ. So IJ, side IJ, is congruent to side LJ, and that is the definition of a midpoint. So definition of midpoint. And I marked them as I go. So I now know that this is congruent to this. We also know that HK has a midpoint of J. So HJ is congruent to KJ by the same thing, the definition of a midpoint. So we know this is congruent to this. Okay. Now we want to look, what else can we know? Our givens don't really tell us a whole lot more. But if you recall, what kind of angles are these? They're back-to-back angles, so they're vertical angles. So we know that IJH, angle IJH, is congruent to angle LJK because of the definition, I think it's not definition, vertical angle postulate. And they're on the other side, so if you ever get stumped, you can always look at the postulates and definition and theorem to find out what you're looking for. Vertical angle postulate. So now if you look, we have a side angle and a side here, and corresponding side angle and side here. So we can say triangle IJH is congruent to triangle LJK by side angle side. There we have it. So we just proved these two triangles are congruent by side angle side. So again, you start with your given, you look at what it's telling you and try to find stuff from it, and then from there you try to prove it. So let's go ahead. There's a you try. So I'm going to pause for a second and let you try your you try. So go ahead and give it a shot. All right. So let's look at it. You should have given it a try. If nothing else, you should have your two givens because that's already stated there for you. You know that WX is parallel to YZ. And by the way, this is Y down here. It cut off in the hole punch. And you also know that WX is congruent to YZ. So we can go ahead and mark that. So WX was congruent to YZ. That was given to us here. That's two things we know. Well, if we know that these two are parallel lines, right, because it told us these are parallel, this is a transversal that cuts through them. So what kind of angles are these? They're inside your parallel lines. They're on opposite sides. So we know we have alternate interior angles. So angle WXZ, that's right here, and angle YZX, right here, are alternate interior angles. So we now have a side and an angle on each one. So finally, we know that a side has to be congruent to itself. And if you flip back over, it's the reflexive property, which says AB is equal to AB, but it can also be AB is equal to BA, depending on how you write it, because AB and BA are the same line. So when you write that, it's congruent to itself by the reflexive property. You now have a side, an angle, and a side. So we proved them congruent by side, angle, side. All right, so another one, I'm going to pause again and let you give it a try. So go ahead and see what you can do with it. All right, so let's look over this together. You should have tried it again. If you can't get any further, you should at least be able to get to the givens. So you're given that JM bisects angle J. Wrote that down, given. JM is perpendicular to KL. Wrote that down as given. So we know if JM bisects angle J, right? So this is bisect. That makes these two congruent angles. Each of them are congruent to each other. So we know that KJM and LJM are congruent angles by the definition of this bisector. Okay. We also were told that JM is perpendicular to KL, which makes this a 90-degree intersection. So LMJ is 90 degrees and KMJ is 90 degrees. And that's the definition of perpendicular lines. Well, if they both equal 90 degrees, by the transitive property, they have to equal each other. So we know we have two congruent angles here. We also know that this side equals itself. Anytime you have a side that's shared by the two, you're almost always going to use the transitive or the reflexive property. So reflexive property says that JM is congruent to JM because it's the same for both triangles, right here. So now we know that triangle JMK is congruent to triangle JML by angle, side, angle. Angle, side, angle. They both have it. Okay? So that proves it by angle, side, angle. All right? And go ahead and you're done with the video. If you've gotten this far before the class period ends, go ahead and either you can work on your IXL, make sure that 5.1 is turned into the basket before you leave. If you just got a few minutes left, just kind of sit quietly and behave yourselves.